Okay, so I didn't want to take a whole lot of time going over this one.
Didn't we already go over it?
I didn't go over this one, but you now have the answer, so you could like go through it. And the answer kind of makes it make, I think, a decent amount of sense. So I was not going to go over this one. If you want to, like, I totally can do after school, or if we have a time right before the test, if you want to ask questions on it, we can go back to it. I wanted to do the new thing today. So I think we're going to say Wednesday of next week. Woo! A week from tomorrow.
That's no big deal. It's not like I have 2 science essays that day or anything.
Awesome.
Wait, that's when Watson's thing is?
Yep.
That's okay though. Let's keep it Wednesday. We'll be ready.
Yeah. It's not going to mean I'm going to put more on the test, so, you know. Today's the last volume thing we have to do. And I'm hoping that tomorrow and or at least Thursday and Friday, we're going to cover one more small mini topic, and then that'll be it. And then we're basically finished everything that AB does. So if you were in that class, you'd be done.
I'm going to drop that class semester.
Yeah, can we do that?
Then,
Some of you I will ask to drop. Just kidding.
what? Thanks.
I'm just kidding.
I know.
But
Wow, you're a jerk.
I know. Zach asked me yesterday if I liked him.
Did you say no? I asked him to no. She likes me.
Really?
Yeah, I was like, do you like me? You're American.
I can tell you the truth about that.
She really does. But I really did.
She does. I'm totally kidding.
Okay, it's like a mutual thing, you know? So I like her.
And what's the answer to that?
I don't know. Lukewarm.
What about me?
Isn't it obvious?
And she hates you.
How about Jim? Yeah, what do you feel about Jim?
I love Jim.
Like Jim Cross, we all know that.
No, like Jim with the bow on the end. It's like one of my favorites. I'm not being sarcastic. I love Jim. It's not actually. It's Tuesday.
It's Friday.
Friday.
Good to know.
Only Tuesday?
Right? I know.
Friday.
I
Are you
know.
recording this?
This week is awful.
Tuesday
Yes.
sucks.
Friendship Friday.
Tuesday's bad.
Not Tuesday.
All right, so I thought I would hand out notes.
Can you do that problem?
Didn't I write you a note one time?
Den.
Did. You did.
So here's the worksheet while they
Right out of tissues.
lab about
I
random
put it
things.
downstairs probably. I had like a little file for myself. I put it in there.
I love the Thursday one.
This is
And
terrible,
like my filing
but
cabinet, I
blurry.
have like a
Sorry.
folder. No, down in the planning center. Why, Matt? Did you want it back? Have you changed your mind?
He wanted to give it to someone else.
You want it framed and mounted on the wall?
Yeah.
I recall
You'll
it was
just
something
have
about
to
being the peanut butter
see it
to
when
your
you get it.
jelly. Something like that. It was something like that.
Your birthday, somebody.
It was like the honey to his whatever.
I think my birthday's on
Friendship
Friday.
week.
Is it designated? Just.
My birthday's on Friday.
Birthday's on a Wednesday.
Okay. Are you ready?
My birthday's yeah.
Awesome. Okay, so these are very different. We're not going to be finding volume, and we're going to use integration to do it, but it's not going to be from the process of revolving anything. They're going to like explain to us the way the solid looks, and we're going to have to kind of figure it out from there. So the wording will be very different, and you'll be able to easily figure out that like this isn't normal because it won't say revolve. This is not volume of revolution. This is finding volume with known cross sections. So take a second and read the first one, please. Probably doesn't help those at home, but
And it won't film.
it won't focus the print.
Yeah.
Shut up.
It's a cross section. It's a cross section like this.
Oh, that's what we're gonna get to. That's right.
Let's see.
Good stuff.
Awful stuff.
Okay. Mathematician has a paperweight. whose base is in the shape of the region between the x-axis and one arch of the curve y equals sine, or 2 sine x.
Basically, it's just
So basically, like, y equals 2 sine x is just sine, what did the 2 do to it?
Bigger amplitude.
Just gives a bigger amplitude, so it goes up to 2 instead of only up to 1. So here's one arch of it. And they're saying the paperweight has the base that has that shape, the area between 2 sine x and the x-axis. Okay, so you really have to be visual when you start to think about this. That the base of it straight on one end and then it's curved on the other end. So I'm looking at it like sideways, as if the desk was that way. Each cross section of this solid cut perpendicular to the x-axis is a semicircle whose diameter runs from the x-axis to the curve. Find the volume of the paperweight. Okay. What they're telling you, that's what the bottom of the paperweight looks like. And it's made up of semicircles whose diameter is basically the height of the curve. So like here and then coming up out of the thing is a semicircle. And here coming up out of the thing is a semicircle. And here coming up out is a semicircle. And here coming up out is a semicircle. All the way across. So I have semicircles with tiny little diameters here. And semicircles with biggest diameters here and smaller and smaller and smaller. Can you picture this at all?
No.
I know, right? I tried to find a couple examples online, but I didn't have a whole lot of luck, so let me just show you what I found. I don't think I'm going to be able to get that down.
can't see that.
So let me just first say, the shape that they tell you the cross sections are blah is going to change. So this time it's a semicircle. Very often it's like the cross sections are squares. So they've like made squares have this length and then they build them up on top of each other. So like I said, I tried to find a couple of pictures, but I didn't have a whole lot of luck.
Wolfram Alpha.
Well,
Yeah.
this is Wolfram Alpha,
Is it? Oh, yeah, it is.
but hold on. It still wasn't all that good.
I don't believe it. Then you weren't using it right. Yeah.
What's that? It's like, so, okay, this is one example of, let me get this a little bit bigger actually. Where did I put that thing? It's not this example, but what it is,
Why don't you click on the one that says cross sections?
oh, look at you, being so smart. So they took a base region that's a circle, and for this, they filled it with rectangles, or I guess maybe squares. I know, rectangles.
Rectangles.
Go to semicircle.
Click on
Yeah,
sections.
but-
You have to go up.
I was,
Click.
can I?
Go up.
Click.
That one.
Shut
Interact
up.
now.
Hit,
See, but like, it's not
hit
letting me.
interact now.
Yeah, but I don't know if it'll let me, because I have to have like, privileges.
Why don't you have proof?
I don't know, because they hate me.
Download it.
Download
It's not gonna let me.
Download
Where's
it.
my
Just try it.
Hey, mic drop.
No what?
Faculty, teacher, government.
Government.
Just
That's great.
It's not gonna let me, I already tried this.
Go.
You
Try
didn't
this.
try hard enough.
Yes, I did, I tried it the other day, because I thought you guys would benefit from it. Because I care.
You don't care.
Well, that's true. No, I do, I care a lot, shut up.
Click there for options.
Click here to get
Click that
started.
yellow bar at the top.
All the way up at the top. Up at the top.
That.
Yeah. Download file.
Woo!
Hooray.
Do you think it's actually gonna work now?
Nope. I hope it's a big virus because everything.
It's full from alpha.
Still it's not, right?
What's going on here?
I already did this.
Already
Yes. See?
Do it again.
Let's just do it for 40 more minutes.
I'll try it one more time.
Wait.
What?
Well, if they send you an email, could they send you an email to like
Oh, maybe.
download it? Jim, fix it.
You have an apostrophe
Jam.
there.
not the right.
Ah.
It doesn't.
Come on, James. Just
Download it.
Oh,
Run.
Woo!
on everything. Like,
You
it's
might get
so
problems when you
fast.
try to install it though.
I know.
No,
If Mike
she-
was here, I think he could do it.
If
No,
Mike
he
was
Mike would've had
so
it done
fast,
today.
Mike hacked the school network.
Yeah,
Multiple
Mike,
times.
it's your fault if this doesn't work.
The school had a security system before Mike was in here. He just found ways around it.
Yeah.
Seriously?
2 seconds.
that last
Oh my god.
Run!
Oh! I told you.
Mike could do it.
Yeah.
I'm sure Mike could do it.
Wait, can't you click on that or no?
No, it's just a picture.
How about the other picture?
This is like actually giving you at least a little bit of an idea of what it's like. Except instead of
Thanks,
the
Corey.
half of a trig function over the x-axis, they did a circle. And then they're putting rectangles in it forever. And it creates that shape. We don't see the back of it, but that's the shape that it's going to create. You don't have to be able to visualize this stuff, okay? It's helpful if you visualize it because like maybe you kind of get what they're trying to tell you to do, but you don't have to. So they're basically just, they're giving us a way to find the volume of different shapes that are made in this different way. For example, okay, this book is made this way, or I could think about it in this way. I could say this book has a base of like, you know, x equals 0, x equals 4, and y equals 4, something, whatever. So it's got like this like rectangular base, and I could say its cross sections are rectangles. And if I added up all the rectangles all the way through, I would get this shape. That would be stupid because we know the volume formula for this. But there's going to be stuff that we don't know the volume formula
sorry.
for, and we're going to be able to use calculus to do it.
So how do we do it?
So all you got to do is, I kind of put like little steps on here, but
I'm guessing we have to
sketch the
integrate
graph. The second thing you're going to do is figure out a formula. Figure out a formula for what I called A of x. A of x is going to equal 1 cross section. Okay, the word cross section means if I cut this down, you know, wherever, if I cut through this and I looked at it, what shape would I be looking at?
Half circle.
So I'd be looking at half circles. They're going to tell me the cross sections are whatever. So in this case, my cross sections are semicircles.
I'm sorry, I'm having so much trouble visualizing this. Is this shape like?
It's like a croissant.
We should bring
It's
in
like
Play-Doh.
It's like a
Well, it's flat on the bottom,
it's
and then
delicious
it's got-
as well.
it's rounded,
So it's like.
and it's rounded as I go up, and like it's got the biggest roundedness here, and then like less rounded, less rounded, less rounded. Like less high, I mean.
Okay, but
That's high.
it's like the bottom's flat.
Bottom's flat.
So it's like.
I imagine it as an
I-
armadillo.
Okay, armadillo kind of works actually.
Show me an armadillo.
Yeah, armadillos aren't rounded on the bottom.
Or flat
This
on
is
one
this is
side.
rounded.
An armadillo lying on its side.
That's a circle.
Okay.
They're not round on the side.
It's like a half a sphere.
Croissants.
Kind of, but it's not spherical. Okay, it's not spherical because
Is it like a
It's like a stretching out a croissant.
half a football's probably better. It doesn't
Yeah,
come.
half a football.
Oh yeah, it does come to a point.
That's a good description.
Half a football.
No.
Take a football and slice it down the middle. Yeah.
No, because it's
But
That's
then
a quarter
you
of
have
a quarter of a football.
that edge. You have to pull it down and like staple it.
So it's not.
If I slice the football in half, I kind of have that idea.
Yeah, but it's not rounded on the bottom.
Can I
But
draw it?
it's
I know,
not
this is-
rounded on the edge.
That's not round on the bottom either.
Look at those circles.
Can we learn how to do this, please?
I'm gonna try to draw it. I think I know how to draw it.
Okay.
Okay.
It doesn't really matter what it looks like.
Should.
Watch it.
Yeah, that's from like the side view.
That's the side
It's
view.
from under.
No, that's
And then
the
it
side
goes like
view.
that, and then it's like,
What is hope drawing?
like, this is like,
It's a taco!
no, but.
Oh, it's a
Wait,
taco.
stop,
It's a taco. Let's go to Taco Bell today.
Okay.
12 pack.
Like,
12 packs of tacos.
No, I
Fried
was
steak, you know what?
Okay, yeah.
Yeah.
I see it. Uh-huh.
Yeah,
so-
yeah, but it's not round enough.
you see under here, it's like that.
Yeah.
So
Yeah.
that's
Yeah.
the back of it.
Yay!
Jen, teach me
Sorry, it's
something.
okay.
I want to learn.
Yeah, that's right. Again, it doesn't really matter. What we have to be able to do mathematically is come up with an equation for one of those semicircles. So,
The piece smooth though, so it's not
Just-
linear.
a semicircle's equation would be what? What would be the area formula for a semicircle? 1/2 pi r squared, right? Okay, it's half a circle, so it's pi r squared divided by 2. So if this is our semicircle, and the diameter is the height of the curve, what is the radius of this semicircle?
Divided by 2.
Yeah, so if this curve is 2 sine x, the radius of one of these semicircles is half of that. 2 sine x divided by 2. So the radius is actually sine x. So, to find the volume of this thing, all I have to do is integrate or add up the area of all of these semicircles from left to right, just like always. So from 0 to what? Where's this point?
Pi.
Pi. Okay, from 0 to pi, I have to add up 1/2 pi times the radius squared, and the radius we said was sine x. The pi and the squared have nothing to do with the other stuff that we did, where we rotated stuff around the x-axis and had pi r squared. The only reason why I have a pi r squared is because the cross-sections were semicircles. If the cross-sections were something else, my area formula would be different. For example, let's just say now, same problem, let's make the cross-sections squares. They're squares with their base in the xy plane. You don't really care, but you could fit a square into this a bunch of different ways. Let's just say that instead of semicircles coming up out of it, we've got squares, like I can't draw. Just
Would that be like a curve beyond top?
It would be curved. It'd be flat on top.
It'd be
like a cylinder cut.
It'd be like a cylinder more, because it'd only be flat for that like little tiny bit, and then it goes down and then goes down and goes down. So it would end up being curved, but it'd be straight on the sides. Good.
Yeah.
Cylinder.
It'd be straight on this side.
Yes.
The flat side on the bottom, it'd be straight up there, but on this side it wouldn't. It would be curved, and it would be like.
But on the other side, it would still be curved.
Yeah.
It would be like half a cell.
No, more like
that
a
would be flat too.
part of a sphere.
The other side would be flat too.
Like a cylinder
Like-
divided
No.
by the diameter.
A quarter of a sphere?
No, because the squares are getting smaller in width, so like.
Yeah, but it would be. Oh, so they also show in height.
It's a quarter of a sphere.
If this is the base, and this is the flat part, and this is the circle part, on the flat part, the squares are going to be straight up, totally flat.
Yeah, but
As I go around, the squares are like smaller, bigger, smaller. So like they're going to round out over here,
It's a
and
quarter
round
of a
out on
sphere.
the top would be flat over here.
I've been saying
So
for like
it's a sphere cut
ever.
in fourth.
If you say so.
It doesn't
Yeah.
matter.
Doesn't matter.
It makes sense.
So,
It's basically
I wish I could actually say.
It's an impossible geometric figure.
right. That's why we don't have an area formula already. Area formula
Then
for
how do they
it
have a
already.
physical-
Yeah, can we get some clay or Play-Doh?
Yeah, exactly.
No, really. that
If,
would
seriously, if
be
we had all the time in the world, I would love to do that.
No, we
Your
could play
final
that.
project, not the exam, but your fourth marking period grade is going to be half of your test and half this stuff. You're gonna like make your own things, but we have to
What?
wait till
So we
after
just
the
have to wait
test.
till fourth.
Wait, so we're using this at the end of the year.
Yeah.
What do you mean?
So we have to remember this.
You just remember for the exam anyway, but yeah.
Or spoon.
Alright, so the area of a
So we have
square,
to be able to comprehend impossible geometric figures.
later you
Good.
will.
Do
No.
this in Rubik.
Okay, so the area of a square is the sides squared. What is one of the sides? How can I represent just like,
Sin x. So.
yeah, just the sine x minus 0, or just 2 2 sine x. So if the cross sections are squares with their base in the xy plane, the volume is going to be the integral of 2 sine x squared from 0 to pi. All I have to do is figure out an area formula for the shape that they're making the cross section be. They give you squares like 7 times out of 10. They're the easiest, but it could be circles.
What about triangles?
Okay, so
And
AX
we're
is
trying
the
this.
cross section.
What's that? I'm sorry.
AX is the cross section.
Yeah. AX represents like the area of a cross section. So let's look at number 2 because it gets a little bit harder.
Yeah.
But same, no, it just gets different.
Do you use your calculator?
And then yeah, use your calculator to get the answer.
Does
Same.
it make it 3D mold?
Can we make it 3D mold?
No, my calculator. I want my calculator.
Angie.
All right, take a second, read the next one.
What do you need?
See if you can draw yourself a picture, not necessarily of the cross section, but just what the graph looks like. So what the base of the solid is going to look like. Just so curious. You guys all know what this looks like? How to calculate it?
I have no idea what any of it looks like.
Are you serious?
Yeah.
I don't know.
Oh, look, we did this like for 18 years last year.
Whoa. Last
How
year.
does that work?
How did these years go?
So the square root of x, the negative square root of x. And they're telling me we're going from 0 to 4. So that's my base. Okay, so first you need a base. We're going to give you a graph. It shouldn't be that complicated. There's your base.
This.
We have an AB, and on the back a C and a D, of 4 different types of cross sections that they're going to, let's see if we can put into here. I don't know if we'll do all of them, we'll see. So what they're doing is they're building a 3-dimensional solid for you and asking you to find the volume of it. They're building it by taking a function, letting that be the bottom of the solid, and then telling you it's made up of a bunch of squares, or an infinite number of squares, or an infinite number of circles to create this weird shape. And that's kind of it. It's just that it's really hard to picture these shapes. So if we look at A, find the volume if the cross sections are circular discs with their diameter in the xy plane. It's important to say because a circular disc could go a lot of different places. It could be just like tangent to the base and come out all the way. We'll never do that. That would be crazy. But that's why they're like making it super clear or trying to make it super clear.
Crazy looking.
Yeah, it wouldn't even work.
That would have hurt.
I don't even know how that would work. But so they're saying that the diameter of these circles, so let's say this is the diameter of the circle, comes out and underneath. So now we do have a bottom and a top to it, like it's not just flat. So in the last 2 we had a flat base and then like the semicircles came out of it or the squares came out of it. This time the circle is going to have its diameter in it and go through on the bottom and through on the top. It's going to be circular, circular, and the circles are going to get smaller and smaller this way. If I looked at the bottom of this thing, what would it look like?
Circle.
A flat circle. Okay? If I looked at the bottom of this thing, if I could like go in the board and do it, I would be looking at a circle. Because the bottom's going to be like the biggest circle. What radius will that circle have? 2. It'll be the square root of 4. So it'll have a radius of 2. This y value down here is 2. So anyway, that's what it's going to look like. But all we need to do is to find the volume of this thing, we need to find the area of one of these circles. The area of a circle is pi r squared. And what does r equal for this? What's the radius of one of these circles?
Root x.
Root x. So the volume is just the integral of pi, I'll just for your notes, whatever, square root of x squared
0 to 4.
from 0 to 4. Okay, you can do this on your calculator. This one's also really easy to do by hand. Are you comfortable enough now that you can you know what to do from there?
Yeah, just like that would be. Well, yeah. Probably not. But you can go on.
Well, either put it in your calculator, or this is pi x from 0 to 4. Okay, I could bring the pi out front. And then I could do this whole thing by hand. So this is like pi times x squared over 2 from 0 to 4. So pi times like 8 minus 0, so this is going to be 8 pi. Who cares? You can do that on your calculator or go back and remember it by hand. Get it? Herpes. Oh, sure, get it? What?
Herpes.
What did she say?
I did not say herpes.
Was it herpes?
I stopped myself. I wanted to make sure. I saw Eric look and I wanted to make sure you didn't have a question. I might have said, like Eric? I don't know. Shut up. Alright, try. Don't worry. Try part B yourself real fast. Real fast. Like,
Oh, this is really fast.
22 seconds. Just kidding. It's squares, so just try it.
Squares.
So if we're not able to visualize this all the time, it's still.
You don't have to visualize it. Just have to be able to get an area formula for the cross section, and that's it. I don't know how the heck these things look. They're bizarre.
This one looks like a football.
Yeah, that's one.
Like a quarter of one.
As you say, it's not like a football. It's going to be a square at the bottom.
Like you cut it in half horizontally and then vertically,
Why do you go all the way? Yeah.
and then again.
But yeah.
Just say so. I'm not a good visualizer.
Volume's always high, right?
It will be. Okay, so if we do the volume, it's the side squared, because it's a square, to represent one side of this thing. I have a couple of options. Like, it is going to be 2 root x, okay, because it's a root x on the top and a root x on the bottom. But what if the two curves weren't the same? How could I find, like, that height? It's the same thing we did to find, like, the area stuff.
One function plus.
Do it minus. If I do root x minus negative root x, that's going to give me 2 root x. Top curve minus the bottom curve will give you the width or the height of that thing. Okay, so top curve minus bottom curve will give you the height of the square. So the volume is the integral from 0 to 4 of 4x. If I use that. It's not that bad, right?
Okay.
Nah? Do you have a question? Are you sure? Okay, flip it.
Oh.
Oh, let's just try one of the following two. Because they're,
C is a lot harder than D.
think?
Definitely. Are you saying that the diagonal?
Oh, C's a lot harder than B?
D.
Oh, okay.
Is the diagonal of the square going through the plane, or is it coming out of
The diagonal of the square is on the plane. So the square is like pointing out and pointing in.
Like the 4 is the diagonal on that
Okay,
area.
so let's try C,
the? That's the
Basically a
diagonal.
triangle.
Okay.
Yeah.
basically. So now it's a
Great.
square, and the diagonal of that square is in the plane, meaning that like, here's the square. This, how can I represent that distance? This is the 2 root x. Okay, the square, the diagonal of the square is in the xy plane, so the square is actually coming out at you like a triangle. I'm going back to the board like a triangle, you know? I got like the point coming out and the point going back down. Kind of looking at it like a diamond, although it's a square. So that's what this shape is going to look like. This is going to be all I need to get it. If this is a square and this is 2 root x, how can I represent the sides? How can I find them?
Well, it's just a triangle. You can do base times height, but not divide by 2. Because it's 2 triangles.
True. Okay, yeah, sure. We got to get the base and the height. But if it's a
Well,
Divide by
no,
root
the
2.
base is the diagonal. So the height is root x. And to find that for that triangle, you divide by 2, because there's 2 identical triangles, you just would divide by 2.
you're talking about like,
What are you talking about, Jimbo?
Yeah, really.
Yeah.
this is 2 root x?
No, the base is 2 root x.
Yeah,
That's root x.
and the height is root x.
Just
He's saying if you
triangle
flip it over,
square sideways.
if you make it like,
I get it.
look like a diamond instead,
Yeah.
then
And
the
then you
base
cut
of
it in
the
half.
triangles are 2 root x, and the heights of each triangle is root x.
Are you sure about that?
Yeah.
Yes.
The
Because
area
it's
of a
a
triangle
square.
is 1
Oh,
half
yeah.
base times height. You
Okay.
just don't 1 half it.
No way, that does work.
Wait,
I got your back, Jimbo.
I can't visualize.
I wouldn't do it that way, but it totally works. It's like perfect. He was saying, turn the triangle on its like side-ish like that. Make this be like triangle number 1 and triangle number 2. And do like 1 half base times height and 1 half base times height, with the base being 2 root x and the height being root x.
So it
I-
just be base times height.
Yeah, that's fine. I actually, instead, which is totally fine, I looked at it like this, and I tried to get my sides of my square, and I know this is a 45, 45, 90 triangle because it's a square. Do you remember how to go from hypotenuse to side?
Divide by root 2.
Divide by root 2. So this is 2 root x over root 2,
That's just disgusting.
I guess.
So the base, like, the base of the shape would be a triangle,
I like this.
like, or it would be a diamond, and then like.
But then it's just
Okay.
I know it's gross. Anyway, whatever way you want to think about it is fine. I did it this way, so when I did my area, I went from 0 to 4 of 2 root x root 2 times, oops,
I'm not gonna do well this chapter.
times over root 2. But you would get the same thing as if you did it that way. We don't need to do the equilateral triangle. Why not? I mean, why do it? I haven't seen that ever come up, so. Okay.
I'm sorry.
That's okay.
So we would take the cross sections like this for that problem? Okay.
Alright, the problems to try are these 2. One of them, they're both square cross sections, so they're not that bad. We're gonna move on tomorrow, so can you do this tonight so that you can like, if you have questions, you can get an answer, and then we can move on. Well, thank you so much. I appreciate the seconds consideration.
Where do you have this?
What's that? Do you already have both of them?
Then just
yeah.
like fill in
It's
three.
part of the packet that we got.
No, we don't have these. Oh no, we have this one, not this one.